Good morning, my name is Murray Palmer. The video that you're about to watch is going to be about drilling out rivets on sheet metal on aircraft and removing the skins.
Okay, all right, I'd like to welcome everybody to the class. It's just designed to teach you guys how to disassemble the sheet metal on the aircraft so that we don't damage, first of all, the sheet metal, and secondly, the more important things is the substructure of the aircraft. And so there's a few little things that we're going to learn, hopefully, throughout the day. And other than that, just sit down. So I guess I should introduce myself. I'm Murray Palmer. I've been in the aviation game 50-some years now. I've never done anything else other than aircraft-related work, so I really don't know anything other than that. First of all, I want everybody to be safe. I don't want anybody getting hurt. The things that we can have happen here is eye injuries, hand injuries, and those are going to be the major things that I'm basically concerned about. I'm not worried about anything other than that. So if we are going to be working in the shop, I suggest having glasses, preferably a shatterproof glass, and we'll watch where we aim that drill so that we don't go drilling through our hands. And trust me, there has been lots of people who have drilled their hands in the past or here. One of the things that I get concerned about is in a shop blowing dust around or blowing cuttings off of your working area sort of thing. So if we're going to use that, we just want to do it lightly. We don't want to have high pressure air. So at the off of everybody's drill, they actually have an exhaust unit when you pull the trigger, and that will blow that little bit of loose materials off of the work area, and you won't get anything in your eyes, hopefully. For this, keep your hands clean, or keep your tools clean, and keep them lubricated. Every one of these air drills that we've got, and the rivet guns, should have 1 drop of air tool oil in it every day when you start. Other than that, they're fine. They don't need a lot of maintenance besides that. So 1 drop a day, no more than 1 drop a day, because if you get more than a drop of oil into it, it starts to exhaust it out over top of your work. So if you're drilling out fresh material and you're getting oil on your material, now you're going to have to deal with the oil afterwards, sort of thing. So the key is just a small amount of oil. You don't need an awful lot, and everything will be fine. But working with sheet metal, if you're riveting on some of the air drills that we work with, some of the air tools, extremely loud and noisy. So earring protection, either the earplugs, the ear muffs, whatever works for you. Now, here's the key to this whole thing, material identification. You need to know what you're working with so that you use the right materials. If we can't figure out what that material is, if we can't identify it, we don't want to basically work with, we don't want to substitute, let's put it that way. So in our manuals, there's all kinds of information telling us what that material was. And we're working with the sheet metal. Most of the sheet metal that we're going to deal with here today and moving forward as we go into the restoration of this machine is going to be what they call 2024 T3 aluminum. The most common form of aluminum in aircraft sheet metal there is today. The materials that are on the airplane as we look at it is probably called a 24 ST. Now that's the old designation, and what we've got today is just a 2024 T3, practically the same stuff with small variations in it in the process of producing that material. So we just need to know. And one of the things that we found out when we started to do the canopy restoration, it's made out of stainless steel. We thought, or at least I thought at first, it was 4130 chrome moly tubing. It's not, it's stainless steel. So that's one of the things that we really have to do is just identify what we're working on. And when we get out to the shop, I'll show you different ways that we can identify materials so that you start to understand a little bit more of what I'm talking about. So anyway, here's the big thing that we got to deal with is our drill bit. And I'm sure everybody here has used one in the past, but some people don't understand some of the issues that we have with them. This is your cutting surface right there that I'm pointing with, and right there, okay? Those are the most important things that you have to have sharp, and they have to be at the right angle. So one of the things you're going to deal with is quality drill bits, and we're going to get into talking about size a little bit in a few minutes, and we're going to talk about the angles. But if you buy a new drill bit, it should be this 115 or sorry, well, I'm going to say they're saying 12 degrees. This is what I was trying to get to. This lip clearance one of 125 to 135 degrees, okay? So what that is giving us enough room to drill correctly. We can get improper drill bits and we can get poor quality drill bits, and we can damage the materials more than we're going to be able to use it. And so quality drill bits, I can't express enough of making sure that you've got the correct ones, the correct quality ones, and then the correct sizes. We'll talk about sizes here in a few minutes. I think everybody understands when, whoops, back up. Everybody's understanding that's the shank. When you're putting that into your drill bit, or into your chuck and your drill, that's all you want in. There's where you want to stop the chuck from going in. Don't put your chuck down on this part of your drill bit here. What ends up happening is most of the drill bits that are made have a little tiny flute built into the ridge on that, and it actually sticks out further. And when you clamp it into your chuck, you got 3 jaws biting onto it, and they don't close evenly. So make sure this is where you stop, slide it in so far, and then tighten it up. And we're going to talk a little bit about the chucks. We've got a variation here. We've got some quick release ones. You just close and open by hand. And we've also got the ones where you have a key, and there's three holes around that chuck. And in those chucks, there's 3 individual screws. They have an interference with each other, and if you turn one of them, the other ones will move, but they won't tighten. So when you put the drill bit in, take your chuck key, lock it, turn it to the next one, lock it again, and you're going to find that when you do put it in, there's going to be a little bit of movement. You're going to tighten it up a little more, take the third one, and tighten it up. And when it comes to loosening it, it's just a matter of breaking the one, and then they'll all come loose, okay? If you don't tighten all 3 of them, 2 of them are left loose, and then what ends up happening is the drill bit itself will catch on something hard, or you might twist the drill bit a little bit, and it'll spin. And once it starts to spin inside your chuck, it builds up a ridge of metal. And now that ridge of metal creates a problem for you, because when next time you go to put it in the drill bit, it might you might have interference with the 3 cones, and now that drill bit is sitting there and it's actually wobbling back and forth. You can't get a true straight drill job on it. Okay, we've beat that one to death enough. Let's keep moving on. There's the parts and pieces. I think you're all familiar. You saw that diagram. We'll just move on from there. Again, I got another part. This is just a little bit clearer picture maybe than what the other one was. We have different styles of sharpening drill bits. This is what they call the jobber bit style. This is the most common style you're going to find in the aviation world. You'll get the split point ones and all the other ones that go along. They're really good. You don't necessarily need them. You just want that style. That's going to be your saving grace. 118 degrees from this angle around here is what you're looking for drilling out aluminum rivets, by far the best. Now, one of the things that we got to basically deal with is we've got multiple sizes of rivets. We've got a 3/32, 1/8 inch, 3/16, and 1/4 inch. And we'll talk about those a little bit. Where I'm going to go with this is those 4 common sizes of drill bits it's universal. So you only have to worry about those 4 sizes: 3/32, 1/8, 5/32, 3/16, sorry, and you can go up to a 1/4 inch. We've got a few 1/4 inch ones on the airplane, but not many. So those sizes are really important, that you get the correct size of a hole when it comes to drilling into your sheet metal. But for today, what we're going to deal with, and our biggest concern, is the size of the shank on the rivet. And we'll get into that a little bit further. But why I put this drill chart up here is that in case you don't understand, when I talk about, if I say something to you, well, just use a number 40 drill bit, or 30, or 20, or a 10, or 21 and an 11, or something like that. What I'm referring to is I'm kind of jumping out of the ballpark on you and going into what they call number-sized drill bits. We have on here, we've got metric, equivalent decimal system, there's in the fractional size, I should get up here, millimeters, decimal system, fractional size, and number drill bits. So if I go down here, and I come down this line here, 3/32 down here is the small rivet that I normally will be putting in. All of the rivets that you get on an aircraft in North America are in fractional sizes. The US has dominated that trade, and when we were manufacturing aircraft, during the war, we were using fractional sizes. We have not changed. The aircraft that are being manufactured in Canada today still use those same sizes, sort of thing. So it doesn't make any difference if it's 1945, 2025 sort of thing. They're all going to be the same size rivets. So this one here, 3/32, 5/32 right there, 3/16, the 4 common sizes. Now, what ends up happening is if we drill a hole with a fractional drill bit, which is 1/8 inch in diameter, that's the size of the shank that we're going to have on the rivet. So if we take that and we try to get in the hole, if we drilled it accurately, it's not going to fit, because it's exactly the same size hole as it is for the shank. So if we force it in, we can push that rivet in. What will happen is that we'll actually peel material off of the shank of the rivet. So I'm just going to do a quick diagram here, if I can, just to help a little bit. Okay there. So we've got a rivet that looks like this. Okay, so, well, I should put in all the rivets that we're going to work with. Now, so here's our rivet. This is what we call the universal rivet. That's supposed to be U. And this is the countersunk. CS. Okay, I'll eventually figure it out. Now, what we have, this sits on the outside of the skin, and the skin has to be shaped properly for that to fit in. This particular rivet creates drag. This one here does not create drag. This is what we call aerodynamically clean. This is aerodynamically dirty. When we're talking about a rivet, we're talking about the shank size is across here, like this. So if I go down here, we've got basically 1/8, 3/32, 5/32, and for lack of a better term, we'll go 3/16. I can't write 3/16. Now, the same size for this here. We measure from here down, we'll measure from here down for length, but diameter, it's all going to be the same. So those are the big things that I want you to be concerned about. We'll have, if we're going to drill out at a 1/8 inch rivet, for instance, we are going to drill it. We have 2 choices, and what I should do is say, well, here's our skin, and now what happens, once this is riveted, we have a head that basically looks something like this, okay? So this now, we have and then this will be a skin, 2 skins put together. So to get rid of this, we need to drill into this portion of the drill bit, or with our drill bit, and take out a little bit at the center. This is now gone, okay? So we create a hole in that rivet head. And we'll do the same thing with this one. It just comes down till we get to that point, and all we're doing is just getting the rivet head to go down into starting into the shank. So now we've got a hole. Now we're in a situation that we can remove that rivet quite easily, okay? But I'm going to digress and go back here a little bit, move forward in what we're talking about for materials, and I'm going to come back to this at the end, and I want to reinforce what I'm dealing with there. So anyway, the reason I say go to the drill charts, and we also have, we've got the drill charts to figure out sizes. We also have drill indexes. Okay? So as I'm talking now, if you notice with this one here is basically set up for the wire size that are what we call the numbered size, I should say. And this one here is also this one's also a numbered size drill bit. I don't know if I've got a fractional one here on this side. I don't. Sorry, I don't. Anyway, I've probably got more drill gauges and pictures of them. Anyway, where I'm going with this thing is making sure that if you're going to choose a drill bit and you can't read the number that's on the shank, it will have the diameter of that drill bit stamped right into it. If that's been damaged or the light is bad and you can't see it, you get a drill gauge and you take the shank of your drill bit, drop it into the correct size hole, and it'll tell you exactly the size that you have. And so you want to make sure that you've got the correct one, and I'll be telling you how to do that a little bit further down the road. Okay, so with your drill bits, they're cheap, even though they cost a lot of money. But where I'm going with this thing is if you damage a piece of material, they're not cheap. That piece of material way outranks the cost of your drill bits. So for the use of your drill bits, I recommend good quality drill bits and relatively new ones. They don't have to be new all the time, but if you damage a drill bit, if you bend it, throw it away. You can't straighten them, and when it comes to sharpening them, I guess from a manufacturer's point of view or somebody who's doing a lot of sheet metal restoration, they can't afford to pay, if you're getting paid $30, $40, $50 an hour to fix an airplane, they don't want you standing there sharpening drill bits, okay? So where I'm going with you get more accurate drill bits by purchasing new ones and using new ones. And if they get damaged in any way, shape, or form, don't use them, because all you're going to do is damage the skin or the superstructure behind them. You don't want to do that. Okay, once we've drilled a hole, we want to deburr, we do call deburring. So if we got fresh material, we drill a hole in it. What ends up happening is if you take a magnifying glass and you look at that, you're going to have a whole bunch of stress risers. And those stress risers need to be removed. And usually what I do is I just take a larger drill bit, quite a bit larger drill bit, stick it in the hole, just spin it with my fingers, do the other side of that hole. Do both sides of that skin just to peel off that little stress riser that's right on the very sharp edge of the skin. So if I've got a piece of skin where I've got a hole like this, the stress risers are going to be around there and around there, sort of thing, okay? So what I need to do is I just need to stick something in there, and it's going to just eliminate the sharp edge. You only have to remove less than 1/16 of an inch. You won't even notice really how much you're going to remove. But every single hole, both sides, you're going to do that. You'll also do it along the whole length of the skin, all the way around. And every corner, when we cut new pieces of sheet metal, we're going to radius the corners as well, because if we've got a sharp corner like this, and it hasn't been dressed, there's a stress riser. Now, with an aircraft, as soon as you start it up, it's vibrating. And when you fly it, it vibrates throughout the whole flight. And when it comes, if it's a pressurized airplane, as it climbs to altitude, it expands and it contracts. You've got cold air outside, sometimes you've got warm air inside. You'll have a whole bunch of different things reacting to that skin. And if there's a stress riser there, through vibration, temperature change, even light change a lot of times, sun shining on it, you can start a tiny crack. It only takes a tiny crack, and then propagation will go through the whole skin. Okay? So it's very, very important that we deal with sheet metal and make sure that we get rid of the stress risers on it. So these are some of the tools that we can use for deburring. Now this here one up here, we use that for hooking out. If we've got pieces of sheet metal, we will run into this on our line quite a bit. We're going to have skins that we will not be removing completely from the aircraft, but we may put another piece of skin up in between the outer skin, say, and the inner bulkhead, and now we've got to go in there and we drill a hole. We might have chips left in there from our drilling process, and we don't want that. We've got to get all of those out of there. We can use something like that little tool there to hook it out from underneath the skin. That little piece there should hook it up. This tool here, we use it for running full length of the skins, just to deburr the edges of our skins. Now, these ones here, this is a deburring tool. I don't particularly like them, but they work well once you get used to them. And again, all they're doing is they got a little sharp edge right on there. You can maybe see it better with this one here. This handle here, there's a swivel right there, so you just clamp that in place, stick it in the hole, go round and around, and you start to peel off that those stress risers in the skin. So we want to make sure we got rid of those. Those are just some of the tools, and I'll show you as we get into it further the better ones to use as we go. Rough edge drill. Okay, I think we've already talked about that. I'll just move on from there. So some things that we got to worry about is our aluminum that we've got. With the materials that we got, the material is created in a molten form. It's then poured and it becomes a billet. And then what they do is they start running it through progressively closer and closer rollers. And that raw material, but that alloy that we've got starts to spread out into a flat sheet. Okay, what we have, like with 2024 T3 aluminum, we've got copper involved. There's traces of magnesium. There could be some traces of nickel in that as well, sort of thing. Anyway, what ends up happening is that makes that aluminum as strong as steel is in the same thickness. Okay, so what we end up with, it's lighter. There's some different characteristics than what steel has, but for all intents and purposes, it's the same basic strength as steel for the same thickness of material. The only problem is that that material on the inside, that alloy, corrodes really, really quickly. So what they end up doing is they'll thin it out until they get to around, and we'll say we want to end up with, say, a piece of 25 thou thick aluminum. So what the manufacturer does is they'll roll the alloy out 4 feet wide in rolls, hundreds, thousands of feet long, some of them, and then they'll just cut it into lengths that you need. Anyway, this stuff would be rolled to around 20 thou thick of material. And then what they do is they put 2/1000ths of an inch of pure aluminum on the outside. They roll that right onto that material. And that is a protective covering for the aluminum, and it keeps that core material from corroding. So what we end up having to deal with is the corrosion issues. And we can't allow it to corrode, because you've already seen what happens when it does get corroded. Now that pure aluminum, so 2 thou thick, that's the thickness of your hair, human hair. And there's not a lot of material covering it. But as long as it's not damaged, it will last 60, 70, 80, 100 years probably without any issues, sort of thing, providing that we treat it properly. So what we need to do is when we're working with it, we don't want to scratch that material. We want to make sure that when we do work with it, that if after we've done all of our drilling, we've done all of our deburring, cutting it, bending it, all the things that we end up having to do with it, we're going to then treat it. Okay, we will end up going through some kind of an acid etch scenario so that we can roughen the skin, and then we're going to treat it with some kind of an allodyne solution. And an allodyne solution is a product that will stop it, or helps to stop it from corroding. Okay, but once we've got that done, we can then prime it, and then we can paint it. And priming and painting is by far the best when it comes to keeping your aluminum from deteriorating. The silver, pure silver aluminum, looks great, but really, really hard to maintain. So some of what we're going to do, from what I understand, is going to be a paint surface. Some of it's going to be left clear, and we'll have to deal with the issues that we have to do with it.
So now what I've got here, and I don't know if you'll be able to tell the difference, but that one's fairly close to being center and this one's off center. So those are the things that I just want to point out. So if you've got these where it's centered, what ends up happening is you can take the pin punch, put it in the hole, and break off the head very simply. This one here, being off center, we can't do that because it just doesn't work. So what we need to do is bring the hole more to the center of the rivet. So what I'm going to do is I'm going to drill towards the center of the rivet. As I get closer to the center of the rivet, I'm going to start to raise the drill so that I'm going straight down into it. I'm just going slow. I don't want to cause any damage. Now, so I'll just blow this dust away. So now you see I've moved it a little. I've moved the center of the hole a little closer to the center. So now we'll see if we can actually break this thing off. I might not be able to, but we'll try. Not quite. I'm just not down far enough, and this is what I want to do is test it. So I'm going to come back in again. And I'm still drilling towards, away from where the center of the hole used to be. I'm trying to get more to the center of the rivet head. Okay, there it popped off, so I don't have to do anything more than that. I actually cut the head off. So now we've got that. Now, do we have a hand? Cool. Okay.
Yeah.
There we go. The head's gone. Now you see what ended up happening? That hole became oval and it's not round anymore.
Right.
Yeah.
So those are the things that we really have to be cautious of. We don't drill into the skin.
Right.
Yeah, and that's what we're learning all about.
And that's what the practice is for,
Yep,
right?
And there's your skin off. Wow, just like that. Fix it and stuff like that. What we'll do is we'll just set this skin aside.
Okay.
And the simplest thing is just roll it.
Oh, I see. Okay.
We'll just roll it, put a little bit of tape around it, and we'll mark it for what it is.
Okay.
And then we don't have to worry too much
Okay.
about it.
Let me get some.
There. So that should work. All we need to do is we can just mark it as forward. We'll go up here, and as long as it's someplace that you can see it. Forward, Bombay,
Okay.
leading edge. Yeah, well, we got forward. Forward,
Yeah.
Bombay, skin. An automatic centering punch. There is a spring on the inside of this thing that allows a plunger to make it operate, and it over centers or pressurizes, I guess, this point, and this is hardened steel. And what happens is when I push down on it, and if you'll look at this there, I'll put a little dent right in that table. When you hear that snap, I put that small dent in there. Now if I'm working with a piece of sheet metal, I can mark all the holes I'm going to do with using this. And I also use it for other tools, like things like that, popping out old rivet heads. And if they're proper, they'll come out. They work really good. But if they don't, what I'll do is I'll just take a little more material out. And if you can still feel it, there's probably too much material there. Go ahead. See that? And that's that little ridge, because what was happening is the skin wasn't pressed close enough together when they riveted it. That's the... Now that's probably fairly close. Sometimes you have to...
Yeah, that works.
Yeah, so with something like this one, and I can see that I'm taking material out. As long as I'm taking material out, I know I'm going ahead.
Perfect.